Hi, welcome to the Biomedical Engineering Practice Proposal presentation. We are Group 12, and for our group members, we have Nurul Azhar Hariza, Muhammad Nadarul Aiman, Teo Jingru, and myself, Ng Keng Seng. As for the introduction, an oxygen flow meter is a device that measures and regulates the flow of the oxygen and oxygen humidification. It is normally used in the Department of Pediatrics in UMMC. The oxygen flow meter can be attached to a part of the oxygen tank, or it can be a standalone medical device that measures the flow of the oxygen from the gas tank or a gas concentrator. Oxygen flow meter measures the flow of the oxygen from 0 to 15 liter per minute. As for medical use, a patient needs 5 liter per minute of oxygen supply. Now is the clinical issue. The problem is that the oxygen flow meter is not accurate. This is not safe for the patient. Hence, this is a clinical issue. This article says that oxygen delivery at high flow rates through a nasal cannula can cause nasal bleeding or irritation, as well as dryness of the nasal mucosa. Also, a high concentration of oxygen flow to a patient may cause the absorption atelectacy, significant inactivation, and the release of the free radical while in premature infants. It can cause the bronchopulmonary dysplasia and retinopathy of the prematurity. Thus, the accuracy of the oxygen flow meter is very important to prevent possible harm to the patients. So how do we solve the problem? We can use a sensor. Usually, an analog flow meter uses a metal ball as a flow to measure the flow rate of the air. And a digital flow meter uses a flow sensor to detect the flow rate instead. Now, we want to use a partial differential sensor to accurately detect the flow rate of the oxygen. This is because it is more cost effective. A price of a partial differential sensor is much lower than the price of a flow sensor. And hence, our following experiment that we'll be conducting is investigating the partial differential sensor. That's all from me. Thank you.
Hi, my name is Teo Jingru and I will be explaining the experiment 1 for the BEP proposal. So first of all, the objective of this experiment is to determine the effect of the diameter to the mechanism in terms of the differential pressure. The hypothesis of this experiment 1 is the changing of the diameter of the pipe will cause the pressure to be changed. When the air flows from smaller diameter to larger diameter, the pressure decreases. Besides, when we increase the velocity airflow, the pressure increases. The introduction of this experiment 1 is regarding the laminar flow and also the turbulent flow. The laminar flow occurs when there are parallel layers of fluid inside a pipeline or a tube. The opposite one is the turbulent flow, which is characterized by the chaotic property changes. With low velocities of flow, laminar flow can maintain their character throughout the pipeline. However, when the velocity and pressure increase through the pipeline rapidly in space and time, the parallel flow changes its physical form from traveling in layers to mixing across the tube. Turbulent flow tends to occur in fluids that are dense, flow at high velocity, have low viscosity, and flow through large diameter tubes. Experiment is made to investigate the effect of different diameter towards differential pressure inside a pipeline. A significant change of pressure can be seen when the ratio of one tube to another is increased. This is the apparatus and material that we will use in this experiment 1, which is the PVC pipes, the reducer, the T-pipe, end-cap pipe, oxygen tank, valve to control the volume of the oxygen supply at each time, the sensors, breadboard, jumper wire, and the Arduino Uno board. First of all, different diameters of the PVC pipes are prepared. The end cap is drilled with a hole for a tube to insert, which will be connected to the sensor at the end. And the tube and the end cap are glued using a hot glue gun to prevent the leakage of the oxygens. Then we connect all the PVC pipes as shown in the figure below. And this is the top view of the model and the side view of the model. Then we connect the model with the oxygen tank, and then we connect the circuit with differential pressure sensor and Arduino Uno board as shown in the figure below. The first pin of the sensor will connected to the ground. The second one will connected to the V-in, which is the 3.3 volt. And the third and the fourth leg of the sensor will be left up connected with nothing. And the fifth leg of the sensor will connected to SDA, and the sixth leg of the sensor will connected to the SCL with jumper wire. And then we connect the stretchable tube to the sensor to measure the differential pressure. And then we use the Arduino IDE application for coding part, and then we measure the pressure flow by using a computer as a display. Then the switch of the oxygen is open and the pressure is measured. The volume of the flow of the oxygen supply is changed gradually to get the three different data. The expected outcome of this experiment 1 is as the air flows from small diameters to a larger diameters of a PVC pipe, the air being spread in the higher diameter tubes, and thus by changing the diameters of the PVC pipes, we can have the expected outcome of when diameters increases, the pressure decreases as the air is being spread in the higher diameter tubes. Besides, when we increase the velocity of the air flows, the differential pressure increases. Because according to the Ventry effect formula, the velocity of the airflow is directly proportional to the square root of the differential pressure. When the density of the air, the areas of the tube, and also the areas of the tube are kept constant. That's it. Thank you.
Okay, hello. So, Assalamualaikum warahmatullahi and very good morning to all of you. So, my name is Muhammad Nadar Rahman and I'll be explaining experiment 2. Okay, so first of all, the objective is to determine the effect of changing the placement of the oxygen supply in terms of differential pressure. And then the hypothesis is the readings from the sensor will not change even though the placement of oxygen tank is reversed. So, for the introduction, differential pressure in general is a measure of pressure where the reading and reference value are variable. Differential pressure is calculated by subtracting one of these values from the other. For example, if pipe A flows at 100 psi and pipe B flows at 30 psi, differential pressure will be 70 psi. Okay, following the formula of pressure, force exerted divided by the diameter of area. When we fix the amount of gas flow from the opening of the pipeline, we can observe the change in the pressure across the pipeline when there is change in the diameter of the pipe. According to Bernoulli's principle, the pressure drop across the constitution is proportionally to the square of the flow rate. So it means that the higher the pressure drop, the higher the flow rate. So basically in this experiment, the entrance of the gas from small diameter to big diameter is done to observe if there is any change in the pattern of pressure across the pipeline. However, reversing the flow of gas from small to big and big to small will not change the value of differential pressure throughout the pipeline. Okay, moving on to the apparatus and material. So, for the apparatus and material, we have PVC pipes, reducer to change the diameter, T-pipe, end cap pipe, oxygen tank, and valve in order to control the volume of the oxygen supply at each time, sensor, breadboard, jumper wire, and Arduino Uno. And then for the methodology and procedure, so first of all, different diameter of PVC pipe are prepared. The end cap is drilled with a hole for the tube to be inserted. The tube and end cap are glued by using a hot glue gun to prevent the leakage of the oxygen. The PVC pipes are connected as shown in the figure below by reversing the placement of the oxygen supply. Conduct the circuit with differential pressure sensor and Arduino Uno board based as shown in the figure from the last slide. From the slide that Jinru already presented, connect the stretchable tube to the sensor to measure the differential pressure as shown in figure 7. In the figure 7 that already been shown by Jinru just now. Okay, and then we use the Arduino IDE application for the coding part to measure the pressure flow. The switch of the oxygen tank is open and pressure is measured. And the volume of the flow of the oxygen supply is changed gradually to get the three different data. Okay, what we expected from this experiment is the differential pressure obtained from the two different directions of airflow should be the same. Thus, the differential pressure sensor used will increase the accuracy of the reading of oxygen flow. So I will pass to my friend Eza for her part. Thank you.
Proceed with the third experiment. My name is Nurul Eza Hazira, KIB 190071 17153326. So the objective of the third experiment is to make a comparison of the accuracy between two models of differential pressure sensors with different number of models. So the first model is the ABP2DDAN001PD2A3XX and ABP2MRRT060MD2A3XX sensor. The difference between these two sensors will be discussed later. And the hypothesis of the third experiment is the sensor of the first model is better than the second one as it is more accurate. In line with the reason why we propose this experiment is to find or to create an accurate digital flow meter. Okay, so the introduction is both models are differential pressure sensors, which can be used inside the flow meter to enhance the accuracy of the flow meter, which is in this case is digital flow meter. So based on the number of models assigned to each sensor, the first sensor nozzles are positioned upright while the other facing sideways. The pressure range of the first model is approximately 1 bar, while the second model sensor range is approximately 60 millibar. So the purpose of using partial differential pressure sensors inside the digital flow meter is mainly because the pressure of the gas flow from the tube to another tube will change due to the many aspects, including the diameter of the tubes, length of the tubes, and also the temperature across the pipeline. The existence of the sensor will help to identify the decrease in the flow rates, and adjustment will be made to increase the amount of gas flow to ensure that the right amount of gas is transferred accurately to the users through the Nester cannula. In this context, the sensor will be placed at different tubes to analyze the flow of gas on both of the tubes. So the apparatus and materials that we use for the experiment is the PVC pipes, reducer, T-pipe, N-cape pipe, oxygen tank, valve, a sensor, the first model and also the second model, breadboard, jumper wire, and Arduino Uno. And how are we going to conduct the experiment? Is the different diameters of the PVC pipe are prepared. So the end cap is drilled with a hole for the tube to insert using the driller. The tube and the end cap are glued by using a hot glue gun to prevent the leakage of the oxygen, which can give error to the experiment. And connect all the PVC pipes are shown in the figure 3 above. Conduct the circuit with differential pressure sensor and Arduino board as shown in the figure 6 above. The figure for these two parts is already explained by the other members. So use the Arduino IDE application for the coding part to measure the pressure flow. The switch of the oxygen tank is open and the pressure is measured. And the step 1 to 8 are repeated with another. Okay, so our expected outcome for this experiment is both of the sensor will show two differential pressure across the part length. However, the sensor that has more precise and high accuracy, which shows significant change during the experiments, will be considered for further investigation to make a digital oxygen flow meter. Also, a theoretical value can be calculated and comparison can be made to decide which sensor works best. And I think that's all from me. Thank you.